Part 2 of 7.3, multiplying and dividing rational expressions. So what did we mainly just talk about yesterday? Multiplying. No, not dividing. Yesterday we just did multiplying, right? Right? Did we do any dividing yesterday?
No.
Then what was simplifying?
Oh yeah, simplified. Is that what you said? I'm sorry. Yeah, we simplified and multiplied. Right? Today we're going to talk about dividing, but we have one more multiplication problem. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9. So I've got a rational expression being multiplied by just a polynomial. It's not written as a fraction, is it? It's just a polynomial. How do you think I can handle this?
I just want to do the stuff in parentheses first.
Say it again.
Just want to do the stuff in parentheses first.
Well, what could I do in there?
You can add I can say 3x and then x squared.
No, I can't combine those.
You could reduce the bottom, or like the difference in square on that.
Yeah, not difference of squares though.
Some of difference of cubes.
Difference of cubes. But how would I make that polynomial a fraction?
What?
The second thing,
One.
put it over 1. There you go. That's essentially all we're doing. Then it's just a multiplication problem, right? So, like she said, we got a difference of cubes in the denominator of my first rational expression, don't we? I can take the cube root of x cubed. Can I take the cube root of 27? Can I take the cube root of 27?
No.
Are you sure? Yeah, I can. I can. It's 3. So this is a difference of cubes. So we need to factor it. Do we remember how to factor a difference of cubes?
Okay.
We do a minus b times a squared plus 2ab plus b squared. Oh, I need to make myself some more room. I'll write it up here at the top. A minus b cubed equals a minus b times a squared plus ab plus b squared. Let me make sure I have that formula correctly, written correctly. I believe I do. Yes. Okay. So, I get my a and b values by taking the square root, or not the square root, but the cube root of x cubed. So what's the cube root of x cubed? X. And the cube root of 27? 3. So I plug x in for my a's, and then 3 in for my b's. Okay? And I did write this wrong up here. This is a cubed minus b cubed. There we go. That looks better. So, what are we plugging in for a? X minus, what's our b value? 3 times, what are we plugging in for a again? X. So I get x squared. What am I plugging in for a? X, and then plugging in for b, I'm plugging in 3, so we get 3x there. Plus b squared, what's 3 squared? 9. Everyone okay with that? I'd probably have those formulas written down somewhere closer in my notes rather than having to flip back to our factoring notes. So I'd have sum of cubes, difference of squares, all those special factoring methods. Everyone okay with that? I factored everything that I can factor. Can I factor this any further? Will there be any numbers that multiply to give me 9, add to give me 3? No. So I can't factor anything further, can I?
No.
So, how do we multiply fractions?
Straight across.
Straight across. So if I multiply straight across, I'm going to get x plus 2 times x squared plus 3x plus 9 over, if I multiply anything times 1, I just get that thing, don't I? So x minus 3 times x squared plus 3x plus 9. Everyone okay with how I multiply? Down to the bottom. Can I erase my work here in the middle? So what's going to happen here? Am I going to have anything that cancels out? What am I going to cancel out?
X squared plus 3x plus 9.
X squared plus 3x plus 9. Remember, if I have that factor in the numerator and the denominator, they cancel each other out. I can divide them out. So what am I left with?
2 and 3?
Not just 2 and 3.
Why can't you get those x's out?
Remember, they're tied
No.
to the 2 with a plus. If they're being multiplied, then I can cancel the x's out. But since they're being added and subtracted, they're tied down by that, I can't cancel them out. Or if they were the same binomial, I could cancel. So, I get x plus 2 over x minus 3, because nothing will factor out. Nothing can cancel out, can it? Any questions there on example 4? We good? Can I move on? All right. Okay, now let's talk about dividing rational expressions. To divide one rational expression by another, multiply the first rational expression by the reciprocal of the second rational expression. Rational expressions are closed under non-zero division. So, I just give you the fractions, 1/2 divided by 3/4. Do we remember the little acronym used to divide these? KFC, right? Keep, flip, change. Or some people say KCF, keep, change, flip, right? I keep my first fraction the same. I take the reciprocal of my second one, which means I flip it, right? So 3 over 4 becomes 4 over 3. And I change from division to multiplication. And then that's just a multiplication problem that I can multiply straight across my numerators, my denominators. What's 1 times 4? 4. 2 times 3? 6. It reduces down to 2/3. So we're going to do the same thing with our rational expressions. I've got my one expression divided by my other expression. I'm going to keep the first one the same. Flip the second one. Change from division to multiplication. Just like this. That's all this paragraph is saying. Does that make sense? Can I move on, or are we still writing? I can move on? Okay. So here's our property for dividing rational expressions. Let A, B, and C, B, and D be expressions with B not equaling 0, C not equaling 0, and D not equaling 0. A over B divided by C over D equals A over B times D over C. Kept the first one the same. Flip the second one from C over D to D over C. Change from division to multiplication. Multiply straight across, I get AD over BC. Simplify AD over BC if possible. Is there any confusion on that process? Same thing as with regular fractions. So there's an example here that they give us. We got 7 over x plus 1 divided by x plus 2 over 2x minus 3. It's a rational expression divided by a rational expression. To divide them, keep the first one the same. So I keep it as 7 over x plus 1. You flip the second one. You take the reciprocal of it. So instead of x plus 2 over 2x minus 3, I get 2x minus 3 over x plus 2. Change from division to multiplication. And now this just turns into a problem that we talked about yesterday. Multiplication problem. Right? So then I can multiply straight across. Factor anything I need to factor. Cancel stuff out that's in the numerator and the denominator. We do need to make sure we tell what x cannot equal. So in this case, x would also, I don't know why they don't have it here. X cannot equal negative 1 as well, and x cannot equal negative 2. Because that would make my denominator 0. Does that make sense? Are there any questions before we get into some examples? How many examples do we have? Yep. Can I move on? Here we go. Oops. Find the quotient. 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. How do I divide fractions? What? Help me out, Carter.
You gotta flip it.
Flip what?
Keep change, flip.
Yeah, keep, change, flip. Keep the first one the same. Change from division to multiplication. Flip the second fraction, take the reciprocal of it. So I get x squared minus 11x plus 30 over x squared minus 6x. Everyone okay with that? Like I said, now this just becomes a multiplication problem that we've dealt with before. So could 7x factor any? What? No, it just stays as 7x, right? What about 2x minus 10? Do I have any GCFs I can factor out? Can I factor it as a whole? What's the GCF? 2. 2 times what would give me 2x? X. 2 times what would give me negative 10? Negative 5. Is there any confusion on how I factored that first rational expression? Am I moving too fast for anybody? I can slow down if I need to. Any questions how we factored here? Okay. Let's look at the next rational expression. X squared minus 11x plus 30. Let's try to factor the numerator. What variable am I dealing with? What goes in the first spot of each set of parentheses? X. If I have a plus sign in front of my C value, are my signs going to be the same or opposite? Same. The sign in front of my B value tells me what they're both going to be. What are they both going to be? Minus signs, negatives, subtraction, whatever you want to say. So x minus, x minus. Now I can create my t-chart. 30 goes in the first slot, negative 11 in the second. Looking for two numbers that multiply to give me 30, add to give me negative 11. Someone give me two numbers that multiply to give me 30. 5 and 6. What's 5 plus 6? 11. Are those the two numbers I want? Not quite. Negative 5 and negative 6. What's negative 5 plus negative 6? Negative 11. Are those the two we want? Yes, they are. Does it matter what order I put them in? No. They both have the same sign. So it does not matter which order I put them in. So I'm going to put x minus 5, x minus 6. We okay with how we factored the numerator for that second rational expression? Any confusion there? Over, let's try to factor the denominator. X squared minus 6x. What's the GCF there that I could factor out? X. X times what would give me x squared? X. And x times what would give me negative 6x? Negative 6. Have I done all the factoring I can do? Yes, I have. Any confusion on any of this factoring? You guys might need a quick brush up on factoring, huh?
No, please.
Yes, you do.
No.
Okay, now I'm just going to multiply straight across. Write everything as a product. So I'd get 7x times x minus 5 times x minus 6. We good there? Over 2x times x minus 5 times x minus 6. We okay there? Any questions so far? Now that I've multiplied, I need to see if anything is the same in my numerator as in my denominator that I can cancel out. So do I have anything the same that's in the numerator and the denominator? What? X minus 5. That'll cancel out with the x minus 5 in the denominator. What else? X minus 6. We'll cancel out with the x minus 6 in the denominator. What about anything else? You sure?
The x's.
Yeah, my x's can cancel out here. So what am I left with? 7 over 2. Can that reduce any? No. There's my answer. Look at that. Good stuff. So what can x not equal here, though? X cannot equal 0. I heard 6. What else?
5.
X cannot equal 5. All those values would give me 0 in my denominator. Correct? Everyone okay with that? Does that make sense? Any questions? Can I move on from example 5? This is my last example for the day. Last one. Okay? Find the quotient. 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. So I'm dividing a rational expression by a polynomial. Try. What am I going to do here?
Put that over 1.
Yeah. Put my polynomial over 1. That helps me make it a rational expression. So that way I have something to flip. Right? Because my first one when I'm dividing has to stay the same. So 6x squared plus x minus 15 over 4x squared. What happens next?
Change the sign.
Changes from division to multiplication. And then what? 1 over 3x squared plus 5x. Everyone okay with that? If you just have a polynomial, put it over 1, it makes it a fraction. If you're dividing, it gives you something to flip. If you're multiplying, it gives you something to multiply the denominator by. Okay? Now we just have a multiplication problem. But let's factor first. Up top, 6x squared plus x minus 15. How am I going to have to factor that?
Oh, slide to the right.
Slide and divide. Slide the 6 over, multiply it by negative 15. What's 6 times negative 15?
Is that what?
6 times negative 15.
Negative 9.
Negative 90. You okay with that? So my variable is x that I'm dealing with. Got a minus sign in front of my c value. Does it tell me my signs are going to be the same or opposite? Different. So one's a plus, one's a minus. So I'm looking for two numbers that multiply to give me negative 90. Add to give me 1. Any thoughts here?
Let's say, 10 and negative
10 and negative 9. Is 10 times negative 9 negative 90? Yep. What's 10 plus negative 9? 1. Are those the two numbers I want? Yep. So I get x plus what?
9.
10, because that's my positive value. X minus 9, because that's my negative value. So is that factor now? What? No. We have to slide and divide. What do I have to divide by? 6, because that's what I multiplied by earlier. So I divide my 10 by 6, my 9 by 6. Reduce your fractions. 10 over 6 we reduce to
5 over 3.
5 over 3. 9 over 6 would reduce to
3.
over 2. And I've got fractions left over, so bottoms up. Bring the denominator out in front of my x. So I'd get 3x plus 5 times 2x minus 3. You're going to have to do some factoring. Okay? So, my new numerator on my first rational expression is 3x plus 5 times 2x minus 3. All over 4x squared. We okay there? Okay. Times, I can't factor 1 anymore. What about 3x squared plus 5x?
Can you pull out an x?
Yep, I can pull out an x. So x times what would give me 3x squared? 3x. X times what gives me 5x? 5. Any questions? Can I erase my slide and divide work? Take that as a yes.
There's more.
I asked. Now I'm going to multiply straight across. So anything times 1 is itself. 3x plus 5 times 2x minus 3 all over. It's going to give me 4x cubed. So I got a 4x squared times x, right? Anything I multiply something with the same base, I do what with the exponents? Add them. 2 plus 1 gives me 3, so 4x cubed times 3x plus 5. Any questions there? Okay. Now that I've multiplied, I need to see if anything is the same in the numerator and the denominator that can cancel out. So do I have anything that's going to cancel out here? 3x plus 5 will cancel each other out. So what am I left with? 2x minus 3 over 4x cubed. Nothing can simplify here, right? There's my answer. What can x not equal? What? Thought I heard someone saying it.
3. Oh, snap.
0. If I plug in 0, that'd give me 0 in the denominator.
Is it always 0?
Not always. What other value would give me 0 based on 3x plus 5?
Hold on.
What number would I be able to plug into x to make 3x plus 5 0?
You can do that?
since it was in the denominator earlier. You want to know an easy way to figure that out? Set 3x plus 5 equal to 0. And solve for x.
Oh,
So I subtract 5 from both sides.
we cannot see.
Don't tell me.
Can y'all listen?
No.
Because I got to finish my recording for Canvas. Okay, I'll show it to you on the board in a second. I'm just going to talk you through it though. Okay. 3x plus 5 equals 0. Subtract 5 from both sides. I get 3x equals negative 5. Divide by 3. So x cannot equal negative 5/3 either. Are there any questions about any of the notes that we just took? Okay, here's your assignment that I will put on the board for you whenever I'm done recording.
No sign?
No, there's an assignment. Are there any questions about the notes before I end the recording, though?
No, sir.
All right.